Okay, thanks everybody. Thank you for joining. Appreciate you spending your time with us. Today we're going to be talking about and looking at Azure and Azure Identity and how that interoperates with HashiCorp's Vault. Today I've been joined with Shamila. She is a CSA at Microsoft in the Azure Specialist. So I'm very pleased to have her join us and to talk about the Microsoft side. And then I will be talking a little bit later and going through a demo of how HashiCorp supports some of the concepts that Shamila is going to go through. So over to you now, Shamila.
Thanks a lot, David. So with that, I'm excited to get started and share with you some of the content today. So one of the first things I want to talk about is today's reality that organizations face with hybrid and distributed environment, which is constantly evolving risks that stem from the complex interplay between the on-premise infrastructure, cloud services, and the remote work, especially which has been accelerated by COVID-19. And where the bring your own devices and remote work was highly encouraged by the organization. With this dynamic landscape now introducing us to new challenges, and such as exposing us to our vulnerabilities and cyber threats, potential data breaches, and there's a need for a secure control access now. This is where the concept of zero trust becomes relevant, and that's what we are going to talk about in the upcoming slides. Moving on to the next slide. So with that, let's understand why we are having a zero trust conversation today. If you go back to earlier days of operating the IT environment, where the most of the productivity was done in office on typical corporate networks like desktop, servers, and mainframes. So they think that the traditional security models was typically relied on the perimeter defenses, keeping everything inside the corporate network as trusted. So this tactic worked at the first because it seems to be a good, simple solution. But however, with the rise of hybrid and the distributed environments such as cloud and the remote work being highly encouraged now, the network perimeter has now become increasingly porous and dynamic. This has opened up new avenues for cyber threats and the increase of data and identity breaches. Hence, a new comprehensive security strategy is required to address all of this, and which is what zero trust is all about. Moving on, let's try to understand some of the modern IT use cases in the upcoming slide to highlight the need of the comprehensive approach in zero trust. So first thing first, security is growing broad in the landscape. In addition to protecting the internal employees, organizations must also consider the security of their customers and partners with the increased need of shared resources accessing the critical systems, and data are subjected to some rigorous security controls. And corporate devices now moving to bring your own devices, especially during the remote hybrid work culture coming in place. Organizations must adapt to the diversity of managing the diversity of devices and their associated security risks. Now transitioning the monolithic apps to the RESTful APIs, because it will involve multiple endpoints and interactions requiring a comprehensive approach to authenticate and authorize each API request. And now modern attacks being very popular and going towards cloud and multi-vector, combining various techniques like phishing, malware, and hence a strong authentication is needed along with continuous monitoring, anomaly detection, and threat intelligence to respond and identify these very faster. As we understand that zero trust is a solution that tells us never trust anything and always verify. Moving on to the second slide to understand what it is actually trying to tell us and what are the guided principles of it. So the first thing first, zero trust tells us to explicitly verify everything because you don't know what you don't know, right? Access to all the services should be secure using all the available data points, including the location, identity, device health, etc., to derive the confidence in contextual access decisions. And always use the least privilege access. So zero trust encourages us to treat every user, device, application, or workflow as untrusted, and says that always authenticate and explicitly authorized when required to be accessed, which means that the technologies or services like just-in-time or giving just enough access with risk-based adaptive policies is highly encouraged. And second thing is always assume breach. So never trust anything by default and deny everything and scrutinize all the users, devices, data flows for access. So always log and inspect, continuously monitor all attributes for any sort of suspicious activity. So that will help you to minimize the blast radius with microsegmentation and end-to-end encryption, continuous monitoring, and automated threat detection and response. So as we have now understood the guided principles, let's try to understand how it's being built in the upcoming slide. So moving on to the next slide, which is building the foundation to the Zero Trust. So let's understand a bit more on how is it built, right? Zero Trust starts to focus securing the people and identities and the devices first, because it thinks that these are the primary endpoints for any potential vulnerabilities to happen in an organization's network. Hence, identity became a new control plane or perimeter for security, and ensuring only authorized individuals can access the organization's resources, so that the risk of the unauthorized access and the potential breaches is significantly going to be reduced. As we now understand the basic principles and the foundation to Zero Trust, let's try to understand the business value of it in the upcoming slide. Moving on, digital transformation now being a motive for every organization, let's try to identify some of the business value that Zero Trust is going to add in this initiative. So in the recent study done by Total Economic Impact from Microsoft, Forrester Consulting reports that implementing Zero Trust security strategy in an organization is guaranteeing 92% of ROI in less than 6 months, along with 50% of reduction in data breach and overall reduction of management efforts, and also numerous gains of more than 50% across most of the security practices that can contribute to a more secure, efficient environment, which enables the organization to focus on core business activity, enhancing customer trust, and maintaining a competitive edge in the marketplace. So now let's try to understand the most other common use cases that other organizations have as well, part of their digital transformation need. Moving on to the next slide. Multi-cloud is one of the common use cases for every organization, and that comes with inherently complex needs because identities grow very rapidly, and because each and every cloud provider has their own identity solution that comes with them, and governing these identities is now a huge task for the operations, because it can lead to the risk of accidental or a malicious permission misuse, if at all, if it's being leaked. Then with that, moving on to the next slide, let's understand what multi-cloud adoption is going to bring new challenges to this. So the recently CloudKnox research has found out that 90% of these identities, which has been granted in an organization, are even being used less than 5% for their daily job functions. As with the numerous identities continues to grow, that exposes a risk to an organization infrastructure, leaving identity and security teams as well, having no granular complexity visibility to control the permission sets across their estate. With that in mind, I'm going to hand it over to David to showcase how our partner solution HashiCorp is going to address these multi-cloud challenges. And then over to you, David.
Thank you, Shamila. So some interesting points that Shamila brought up, around complexity with multi-cloud, trusting nothing, using identity to actually identify the individual, and using that as a mechanism to then base your security policies around. So partnership between HashiCorp and Microsoft leverages the HashiCorp Vault product to actually help enforce and address those elements, particularly across the multi-cloud and hybrid cloud scenario. So when we think about that complexity, what we're talking about is moving away, as Shamila pointed out, from that traditional single choke point that happened in traditional on-premise networks that was built around that hardened perimeter, to how do we actually create an identity-based construct. And so to do that, that's a move towards API first. So there's obviously need a mechanism that can support and deliver API conversations around that. There's also then a need to be able to talk to multiple systems, whether that's multiple cloud platform backend, or whether that is other application elements. So GitHub, Azure, being able to speak to both of those parts, being able to get least permissions and least access. So being able to actually identify and get privileged access when needed as a time to need. So on a demand function. And again, Vault steps into this mechanism. And so Vault is our secrets management and key management tool that allows for the development and building of multiple security domains. And so when we think about Azure and another cloud, or Azure and on-premise, you have these two domains that you're needing to connect and talk across. And so with Vault, you can build or use either the SaaS delivery or the on-premise component, or build those the binaries into whatever you want to deliver it in. But you can build these separate security domains that then create a centralized mechanism that allows you to centralize the communications and actually create these separate security domains, which can be then used for tracking down and creating a single point of control for sort of secrets. So if you have, say, a JFrog breach again, instead of having to track down all the separate applications, you can roll it in that centralized place. If you have a key that you think has maybe leaked, or a secret that you think has leaked in a particular area, you can isolate that security domain and still keep the rest of the business function. And again, creating that centralization helps around that whole construct around simplifying login. And so when we think about that login and audit control, what we're now doing is as users log in, and we talk about this a little bit more, but as a user logs in, and that user could be an individual, it could be an app, it could be a machine, we could collate that from a central point of control across all of those different clusters and send that then into a SIEM system. And that obviously means that you're increasing your ability to deploy secrets and events across that architecture. You're reducing your risk by actually getting closer auditing trails from all of those sources across multiple different entities and backends, and then reducing the overall cost by being able to centralize and use a centralized SIEM. From an enforcement perspective, which is where we think about using Vault in controlling access and governance and get compliance component that we were talking about at the introduction, there's 4 key elements that we really break this problem down into, and we'll go into each one of those. But the first is controlling that identity sprawl. So how do we actually understand and link those different control or controlling elements that we need to interoperate with? The second is then how do we unify an entity across that? How do we create an individual that can be clearly marked and understood, that has those different across those different platforms? Once we have the identity defined, we obviously then need to apply some policies and roles around what that individual is undertaking. So again, going back to what Shamila was talking about, and that least privilege, thinking about where we can actually define that, and then taking the ultimate stage, once we have those policies in place, to then add granular tuning around a particular mechanism. So whether that is a particular location, so for example, a particular database is based somewhere, someone from the US is trying to access an EMEA-based one, that then all obviously kicks in the ability that maybe they need to be authorized or have an individual or superior actually sign them off to have access to that. So again, getting that additional granular control over the over your access. And so when we think about that first problem of controlling identity sprawl, fundamentally what we're looking at doing is how do we get a centralized system that can talk to all of these different components? And what we're doing by that is Vault becomes that central point of control and reaffirming that thinking of the choke point, so that it doesn't necessarily have to be an individual cluster. It can be multiple clusters around, but they are linked in a way that Vault can actually understand and create this construct of an entity. And so that entity then has a singular component that we can authenticate, and then Vault becomes a mechanism that authenticates against those different backends, whether that's Azure or GitHub or into Kubernetes. But we can create that single point, recognize the entity, authenticate that against a single source of truth or multiple sources of truth, and then create this necessary information, whether that's a secret, a key, or a dynamic secret, and allow that to happen dynamically based on time. So we use a TTL that actually associated with that secret, for example, that can expire under a particular time constraint. So now, again, going back to the privilege and thinking about the always but always being attacked, is that we are now providing the minimum amount of privilege for the minimum amount of time, so that a resource is a lot harder to be compromised if anyone actually does get those details. And so now that we have created a mechanism to be able to talk to all of the different systems, we now need to think about how we can actually unite that under one centralized identity. And so we created that entity, so in this case Bob, and we'll see Bob a little bit later in the demo, but in this case we have the identity of Bob, and within that we create aliases that associate with the different aspects around that identity. So now in those different areas or systems as it goes and authenticates or logs into, we have a single entity across Bob's interaction. And as I said, Bob could be an app, a machine, or a human. And so now that we have a unified identity and we have our ability to log into our different systems, we can now enforce our policy. And so these policies can be either, access or deny, or some sort of corporate data security component that we build a policy is. And as I said, Vault works as an API. And so the way that we think about applying these policies is with ACLs across the endpoints. So when you mount a secret, you are mounting that at an API endpoint. So there is a path, and we can see the path here for /secrets. And against that, we use the standard CRUD mechanism. So create, read, update, or delete, and create a capability for that endpoint. So as a user who is authenticate, in this case with a username and password, goes to an actual endpoint, we're applying a policy of what they can do to that. So that could be, I can read a particular one, I can view another endpoint, but I can only read certain capabilities. And then additionally, over the top of that, we can then apply using HashiCorp Sentinel, and this is not to be confused with Microsoft Sentinel. I know there's lots of similar names, but using our Sentinel policy to then tie in additional security concerns that may be needed for that data. So, for example, applying multi-factor authentication to that particular endpoint as a secondary form of authentication. So now we have our systems, ability to talk to multiple systems. We have our ability to unify our identity, our entity, should I say, rather identity, our entity, so into a singular component. We now have created our policies, and now we need to then think about how we can authorize those particular actions. And so when implementing access to data, it may be, as I said, in the example that we're going to run through in a little bit later, is a GDPR request. So applying a policy around a one-time access into a resource that allows a user, or requires a user to be additionally authorized with someone. So normally they can access secrets without having to to glean any information or to be authorized, but one particular resource, they actually need to have additional authorization by someone from a particular group. And so again, how do we apply that into that workflow? Well, we use a component called control groups, and this allows us to then tie that together and put in that fine-grained granular control around the user interactions and user user delivery for and access to secrets. So let's take a look at our demo. And so what we'll be doing is taking a look at this setup where we have Bob. We'll be using HashiCorp's cloud platform. So HashiCorp's cloud platform is our SaaS-driven and delivered mechanism built on Azure. So you can actually build this within your cluster. It uses a VNet to connect into your private, or uses a VNet peering to connect into your internal infrastructure components. So when you build on Azure, you connect via a VNet peer, and you can get access to Vault that way. You can also do it over the internet as a raw front end or public front end if you wanted to. Obviously, from a security perspective, that's probably best left for just testing and dev, which is the case I've used here. We have Bob set up as a user and using user pass, so just a username and password, make things simple. And we have a path that he needs someone to authorize. In this case, I'm going to authorize his interaction. And so let's take a look at some of those elements that actually build this together. So this is Vault. We are looking at the front end. So this is the admin console here. You can see that we have created our GDPR data secret. So this is under orders and ACT1, and this is the secret that we're actually providing to Bob. Now, we have an order number and a product ID with a key value pair. So a very simple key value pair that we're looking to actually create. And so what this is based around is we have a set of policies. So we have our manager policy. So this is defining what we can do. So we have our create and update at the authorized component, and we have our create and update at the request. And then from Bob's perspective, he falls under this policy around this endpoint. So you can see our path that we have. So he can only read from that endpoint. So where our secret was stored, that KV component, he can only read from. And he needs, again, from that control group, an authorizer from that group that I'm associated with, that we just looked at, the account managers. And in this case, we need one approval. So obviously this could be multiple approvals. It could be multiple control groups as well. So you could have maybe an account manager and someone from a security group getting into that additional layers of authorization. So again, that granular control that we were looking at. So if we go and log in as Bob, and now we log in with the password. Yes, right password. So always fun. So now we go to orders slash. So this was our endpoint that we wanted to view our secret at. And now we need to be authorized. So from Bob's perspective, he could gain access. This is the assessor association that we need to look up, but he's now having to wait for someone to approve that. So if we take a look at the approver, so it's me. Right password two times in a row. If we go to our control groups, we just look up that assessor. We can see that Bob is waiting to be authorized. And so if we allow him authorization and then go back to Bob's session, we can now refresh this and we can actually see and visit. So now we can see we've been authorized at that endpoint. Even though we had the privileges, we can actually look and see our secret. And so if I now went back to try and look at that endpoint, because I was only allowed access under as a one-time component, then I would have to reauthorize and reauthenticate again to gain those privileges. So with this, we can see that we've kind of really tied these elements together to allow for using HashiCorp's Vault as a single point of control across your security domains. So expanding that field, creating a centralized component that allows you to log, to audit control, apply your RBAC policies, and interconnect across multiple platforms, whether that be Kubernetes or into Azure, and even pulling secrets into GitHub. Now, that interaction allows for obviously the injection. In this case, is for pulling information out in a very human way, so being able to interact with it in a human way. But this could be as part of a pipeline. This could be part of a GitHub Actions workflow to inject that into a automated process of standing up secrets or providing certificates into an automated workflow that then provisions infrastructure behind that. And so, as we sum up, obviously there is a test drive where you can go and look at this for free. There is our products are available on the Azure marketplace, so please obviously go and get some trials out there. There is also that link, which all of these slides will be shared afterwards. So we will actually be sharing these out as well. So you can go to the link and get some potentially Azure subscription. That's the word I was looking for. And so there are a few questions in the Q&A section. So I will just open it up for Q&A for a little while and see if there's any other questions that comes in. At the moment, ones we have are, Azure has their own vault. What is the benefits of using HashiCorp Vault versus the Azure Vault? Aha, great question. So from HashiCorp's perspective, and the way that I've always looked at this is that if you are 100% building just in Azure and you're only using very simple key value pair scenarios, very similar to what I just demonstrated, to be fair, then that use case for Azure Vault is 100% justifiable. However, as soon as you start getting into how do I do this across a multi-cloud platform, whether that's, as I said, into Kubernetes or into multi-cloud, how do I do and apply my certificates or my secrets across multiple workflows? How do I create a least privilege or dynamic secrets so that I'm actually getting just-in-time secrets? These are scenarios where HashiCorp's Vault, working with a back-end identity provider like IAD, really adds a lot of value into that overarching workflow and simplifies the ability to deliver that secrets and key management across those multiple platforms. And the reality is that from where HashiCorp sits, is we usually see this is how do we solve this challenge, particularly in a multi-platform scenario. And so that's where the real value from a partnership perspective comes in, is us being able to solve that challenge from that scenario around delivering across the multi-platform, leveraging an identity provider like IAD. Shamila, is there anything you want to add to that?
Yeah, I would probably add on to the same point what David has just mentioned, right? So probably I have seen typical customers coming from a multi-cloud background is opting out for a single control plane kind of a tool which can provide them the flexibility to operate across multi-cloud and their on-prem as well. That's when the real value of HashiCorp Vault plays in. Other than that, the features what HashiCorp Vault and Azure Key Vault offers is just the same, like data encryption over the transit and the rest. Most of the other features remains as is.
Cool. Also, I mean, the other scenario, the other mechanism around that is also with any of these toolings that we provide, is the ability to interoperate with the lots of different components. As I said, working with GitHub Actions, building that into a workflow mechanism, building it into some form of pipeline. So being able to automate that process, being able to use and integrate this with something like Terraform, for example, where you can pull secrets dynamically into your Terraform run to actually build and create infrastructure. So how do you tie and simplify that overarching delivery of your infrastructure components. And that's where, the ability to tie these elements together really kind of helps.
Yeah. And also, when you are typically building the use cases for your applications, especially in the real Kubernetes or the container world, the secrets may come from different places. It could be from application, it could be from databases, hosting in multiple places as well. So if the identities remains in Azure, yes, then putting them over the Azure Vault looks well. But what if the application has been coded to access across a multi cloud environment, and if your services, example, the platforms that you're hosting, your containers or the databases is in a different place altogether, where the identities could not even brought in to Azure for authorization or authentication. So that's when the real value play or the proposition of HashiCorp Vault can be a good option for you.
And if you want to go and experiment, you can go to, as I said, you can go to the HashiCorp Cloud Platform, so portal.cloud.hashicorp.com. Sign up. There is a dev instance, so you can actually do a free tier dev instance, which will provide you with most of the features and functionality that we've been talking about here, and experiment and get used to how to connect that into your Azure environment, create dynamic secrets, and a wealth of those things. So there's lots of use cases that you can sign up for and start to experiment. There is another question. Will Vault use as a centralized repo to which secrets from different cloud vendors replicate? Yeah, so with the Vault use case as a centralized repo to which secrets from different cloud vendors. So at the moment, I'm not 100% sure on the phrase, but at the moment, what you can do with HashiCorp's Vault is you can use that as a mechanism to have the same secret across different cloud platforms. So, for example, that key value pair that we were talking about, because it's API based, you can access that from anything that is making an API call to pull that secret in, regardless of what that platform is. I think that's what the question means, unless you mean, will Vault actually be able to synchronize with different, say, like Key Vault and I can't remember what it is on other platforms, but and pull secrets from that. I'm not 100% sure. But from a multi-platform perspective, because we talk about Vault as basically an API query, you can use that across any resource that can make that query. So I used a very human-friendly syntax, but you can do that both API and also command line. There is also support for applications agents. So there is a Vault agent that can be run within a Kubernetes environment, for example, to get K8's authentication out from your secrets repository. So in that scenario that Shamila was talking about, for example, if you have multiple clusters and you set up multiple K8s clusters or AKS clusters or EKS clusters, you can have a central again, a central repository that then access that secret repository, secret master across those different clusters. Again, you have the same secret that can be shared across those clusters. So again, having that centralized mechanism to be able to share and communicate with.
Yeah, if I add on to the same point what David has just mentioned, yes, you can use HashiCorp Vault as a centralized repo. If your organization do have a need of multi-cloud and applications hosted all over the place, which can be on-prem, which can be, Azure or AWS or Google, and you want it, and your organization's policies or the security controls enforce a centralized place to store in, instead of storing in each cloud provider's vault, then yes, then you can probably go with a centralized repo, using HashiCorp Vault for everything.
There's a question coming around. If you set up secrets management in different cloud vendors, please suggest a way to migrate to HashiCorp. So what I would suggest is first sign up for that for a mechanism or a Vault cluster that suits you. So whether that's SaaS delivery into a VNet into your infrastructure, or whether that's an actual instance build. There are lots of examples for getting started. So whether, again, using the getting started page within the portal, or there are Terraform examples, because obviously HashiCorp creates and owns Terraform. There are Terraform examples for standing up and driving Vault and getting Vault configured. So that is a really easy way to get you up and going quickly. In terms of migrating your secrets, there isn't yet a tool that will allow you to, that I know of, that can export and import them in. However, you can then leverage that infrastructure to actually then start migrating services or secrets dynamically. So it may be that you then just repoint the application or the consumer of the secret to that API endpoint, and now you have the ability to pull down dynamic secrets.
And I think the next question is, what is the similarity between Azure and Intune in terms of registering the device? Not sure, but it is too relevant for this session. But although, it is similar, Intune devices are also similar to the Azure AD registered devices, which means we will allow organization, to access the Intune portal app, which can probably users or employees use to manage their corporate apps and resources and data. It is very similar. There's no much difference between Azure AD registered device versus an Intune device.
Cool. There is a question about costs, but as I said, that's more that would be more specific around the environment. So I'm not going to even pretend to be able to give a decent answer around that in this scenario. So if you are worried about costs, please speak to one of our sales team, and they can definitely help you. Is Vault a global resource or regional? You can regionalize them. So it is depending on where you want it to deploy. It's supported in multiple regions that have true multi-AZ. So multi within that region. So I think there, and I can't remember off the top of my head, that there's definitely an APAC-based one. There is a couple of APAC-based ones. I think Singapore is on the list. I think Australia is on the list. There's the two that stick out from memory. There is definitely some in EMEA. I think that's London and Berlin, and then you have a plethora in the US. So yes. Again, as I said, if you want to go and play, there is also a really good Zero Trust book that we did jointly and created as just an ebook that we did jointly with Microsoft around some of these concepts that we talked about, some of the key elements, some examples. So again, that's another resource that you can obviously go and download and use as you will. There is going to be a follow-up series. There is a third part to this webinar series that will be coming out soon. So again, please come back and join us for any of those interesting conversations that we can spark. The next one will be around again, following on the security mechanisms that we can use to better increase or better deploy and stand up your environments.
Yeah, and also adding to the same question, is Vault a global resource or regional? Not sure if you're referring to the HashiCorp or the Azure Key Vault, but if it is Azure Key Vault, yes, I mean, Key Vault in Azure is a regional resource. Doesn't mean that you are just your data is just replicated within the region, but we do replicate to a secondary region if in case there's a failure or any sort of disaster recovery that comes with the service SLA, where we typically say that Azure paid regions are the ones that holds the data across to maintain and guarantee you that SLA that we have promised for the key vaults.
Awesome. Well, I think we've covered everybody's questions. I'd like to thank Shamilia for her time and her effort around this. I know it takes up a lot of time and effort in creating these content and these slides and working and rehearsing. So thank you very much for coming and joining us. It was great having you here. Please, everybody, come back and join us for the next, as I say, the next in this series, where we will again touch on security and how we can help build and create a more secure environment for you. Thank you to the team, so Mel and the team, for setting all of this up, and we will speak to you next time. Thank you, everybody, and have a good day.
Thanks, everyone.